activity between ISO and IEEE, you can see that the numbers are getting much bigger for ISO. We may have to come up with abbreviations after a while. Anyway, this particular work on 1451 is being sponsored by Dr. Kang Lee, the National Institute of Standards, who's also chairman of IEEE TC9 for sensor technology. And he is the host of the 1451 Smart Transducer series of standards. I guess Irfan will have these available on a website later. There is a hyperlink here if you want to learn more about it. Or you can just go to Google and type in 1451.1.4 for IEEE, and you can read a little bit about the working group. That working group has been formed, but we are still soliciting additional participants. A little background on XMPP. XMPP came from the original organization back in the 1990s called the Jabber Foundation. That group is now called the XMPP Foundation, which, as you can see at the bottom of the slide here, I've provided a hyperlink, which again you can find on Google, which is xmpp.org. If you wish to learn more about XMPP in general. As you can see, there's a number of RFCs that have been written for the IETF. This is not new in the sense that we've actually had extensive use of XMPP in the financial industry. It's used for a lot of inter-cloud communications, and organizations like Google, eBay, and others, and particularly the ones that use instant messaging, use XMPP or a variant of XMPP at the core of their operations. So these are very large-scale systems. So you can see from the RFCs, it addresses fundamentally some key concerns that you're able to provide security built directly into the protocol. It's not necessary to layer on top an additional security. We also support the simple authentication and security layer, which allows you to achieve single sign-on capabilities, and TLS security, which is a standard supported for smart grid, is provided for in the protocol. One of the most important ones that I like very much is the idea that just like you see for your instant messaging, where you can tell if somebody's online who happens to be a friend and you want to try and communicate with them. Well, we're able to have this notion of presence such that we can know that devices or services are available, which is quite useful when you think about that. Today, we really don't know if a particular device is available when we go to connect to it. You could be actually getting bad data from something that's not even connected. Let me just move forward. I'm going to be talking, you'll see some references through the slide on it's actually a new product that we've been working with as our reference model. It's called the IPDX. And this provides a decentralized client-server architecture, which makes use of XMPP. And I'll hope to show you more about that. I'm going to try and jump right into this as the basis of what does XMPP represent. Now you see in the middle of the slide this triad, which represents a service-oriented architecture, where basically you would have a service consumer who would be in the field, registered with a service broker, and a service provider is also registered to be able to access those particular devices. And you can have multiple domains of use, and that's what we call a service-oriented architecture. And what we're trying to achieve here in the sense of just creating a message channel, a secure message channel between endpoints. And the service broker serves as a applications layer router where we can move messages from a single device and be able to distribute it to multiple devices or applications, and that includes users from the server. And I might point out that that server can exist as a private cloud. He can, on a LAN, for example, or he can exist on the public internet. And that's what we're calling today cloud computing. this is more or less what that IPDX has in it. I'll point out the services that we build into our little box, if you will, is an XMPP server. So that service handles all the transactions via the 21451.1.4. It also includes a web server. It has a sensor service bus where we're able to tie in legacy devices to handle the protocols like Erfan just mentioned. We call that a legacy device adapter, which in concept you could have multiple device adapters residing on the same machine. And the machine has a built-in firewall. Okay. I might mention that this particular device, you can also hook it up. The web server has the capability of communicating with Android devices and Apple devices as well. So being able to use those devices in the field, it's a matter of contacting this server that has this particular type of device with the 1451 XMPP server capability, and you would be able to establish a secured connection using TLS from your Android device, which is not done today. One of the things that I'm going to mention here is something that was in an article that came out in Control Magazine that was regard to, by virtue of the way this system operates, we provide a layer of security. Quite frankly, one of the concerns we get is that we have about an average of about 80,000 viruses that are now coming into our systems every year. And I'm here in an industrial plant at the moment. Our systems are all isolated, and we are not permitted to have internet access. So it's not possible to even get virus updates. And yet we're still concerned about getting virus into the system. Well, during this transition process, where we would maybe convert a MODBUS packet into XMPP, during that transition is an opportunity where we can apply policy, we can look at the particular registers that are being accessed, and if we want to apply restrictions that say, well, only these particular registers can be read or written to, we can do that. And we can do that on a device-level basis. And in addition, XMPP actually uses different port numbers. Most systems today use port 80. And most of the exposures for virus attack are coming from our exposure to port 80, quite frankly. The XMPP utilizes port 5222 and 5223. And that is quite helpful also, because during this transition process, we inspect the packets to see that they're only XMPP packets, and that we can apply the policy to prevent packets from being able to enter the system that aren't authorized. And bear in mind, the system requires that the end device be registered with our service broker, and the channels are all encrypted. So we have multiple levels of security that's built into the system. Some other things we'll talk about later here is that we can apply the same process of transversion to other protocols as well. But this is the fundamental basis. Okay, these are some diagrams. I hope people can see it. I have a white paper coming out that's going to be at the IEEE Smart Grid Engineering Conference in Oshawa, Ontario next month. But I took a few of the diagrams out of that white paper. What we see on the left is more or less what we have today. VPN services, where we try to connect our field network systems to a application like an HMI. And that's a single channel, and it does secure a connection by encryption. And we can put firewalls at the endpoints if we wish. But many of the field devices don't have firewalls today. So we have to add that to the system. I might mention that many of the field sensor networks today, they actually make use of MODBUS at their gateway, which is an opportunity, because now we can even communicate with those gateway devices, which may not have security on their backhaul and would have to have that added. Mike mentioned I'm a chairman for ISA 100, Common Network Management, and we're looking at many of these issues. And the ISA 100.11a system, many of the variants have MODBUS as their common protocol. But again, they don't have any security. What you see in the middle now is adding something in between, which in this case is an XMPP server, and you have to have an N box that connects to your field device or gateway device. But because we are converting the XMPP, which is XML, Extensible Markup Language, we can use it in the middle for display purposes on web pages. We can send it to mobile devices, and we can apply policy and do many, many things, including storing it, aggregating it, whatever we like. We'll learn more about that later. There's a lot of flexibility by having that in the middle and then at the endpoint. To expand this capability for the scale of use in something like the smart grid, the center point is what we change now. We create a federated server cluster, and that's what we see in the internet today in systems that are very large scale, handling millions and millions of devices. And that's what we're seeing here in this depiction, that expansion and getting scalability using XMPP is a matter of applying this to federated server clusters, which can be provisioned either locally, over a closed network, or even over the public internet. And I might mention, the network interface doesn't matter. You can use any wired or wireless connection. You choose whatever appropriate. The most important thing with XMPP is reachability. You have to be able to contact the service broker. So whatever technology you choose to use, that's the most important element. Choose the proper technology or combinations of technologies that achieve the connectivity and reliability that you would need. This kind of shows you a picture of the control and data planes, which discusses more or less what I just said, where you can provision endpoint to boxes pretty much anywhere and have them communicate via wired or wireless. And in addition, we can add identity providers. For example, I show in the picture here. And that's where you can have your single sign-on capability that's tied into the protocol. Won't put too much more of that. This kind of blows it up a little bit more. That shows on the left your public cloud and the fact that you can now use this IPDX or a box using this XMPP server as an intermediate. The interesting part of this diagram that jumped right out at me, it actually made me think of the PBX. When we changed from the analog phone system to the digital phone system, I'm sure there was a lot of concern, like why do we need to do this? But we got a lot of additional services. We got call waiting. We got all kinds of things that were all built into the digital system. And we're able to bridge different systems, create business entities, and this whole thing, what we're seeing today, I think mirrors what we went through 20 plus years ago. But now we're going to make use of the internet and IP. I'm going to restate this. This is the idea of decentralized versus centralized. And what we see on the left is a decentralized approach, which is more or less typical of the way we do things today. I'm in an industrial plant right now, and I can tell you we're hooked up like this is on the left, and we don't have any firewalls, even though it shows it here. That would be the best thing. We have proprietary systems. But if we were using Ethernet, we'd probably need to start thinking about putting it in firewalls. But all the data generally goes back to one central machine. And we size that machine to the appropriate size that can handle the capacity of tags we want to look at. What we look on the right, and bearing in mind what we just discussed, that center server now can be decentralized. We still have the same concerns of adding in firewall capabilities, and we may secure the connections, but our expandability now has become greater. We can add multiple servers in the core, where typically on the left, we would maybe have a redundant server and a primary server. And then we have the concerns with failover. The internet is more like the one on the right, and I think that's what we should be considering. Again, in summary, the objective of our 21451.1.4 standard is to demonstrate that assured interoperability can be achieved, scalability, and security can build in utilizing a common extensible protocol, XMPP. I have quite a list here. I call this the characteristic requirements. And I'm going to kind of go back to my time with the P2030 group, because we actually developed in our task group what we call characteristic requirements for the SMART group. I kind of hope that people looked at it. But one of the most fundamental things of addressing a problem space, I believe, is to state the characteristic requirements that you are looking for. And avoid the idea that, oh, I got to jump to a particular technology. I have to, well, if you want to buy ABB or if you want to buy Honeywell, then that's what you want and that's what you get. If, in fact, you want to be concerned about other things of capabilities, I would say write them down and then maybe see if the vendor can provide it. But on the other hand, since we're talking about something new now, I would say take a look at these kind of things I have on the list. Things like we want to have that we can register the devices. We need encryption on an end-to-end basis. We'd like to be able to have presence where we know that the device is available for use. And we would like to see this ability where we could have this instantaneous change into XML and use XML as a common protocol in something like what we call XMPP. To be able to have end devices viewable on a web browser or on mobile devices. That might be a desire. And have some type of intermediate brokerage, which is what we call a service broker, and that firewalls exist in all endpoints. And that, I'm just reading these off here because I can't remember them all myself. And as Irfan mentioned, many protocols already have profiles. You would still need some kind of profile that defines what kind of device you're talking to. And what generally we do is we perform a hash algorithm so that if that device is changed in any way, we're able to tell. And one of the expectations is with 1451 that this is something that can be added on for new devices such that it can achieve this capability and yet still utilize the same protocols that it's used in the past or transition to new ones. And of course, I mentioned at the bottom the characteristic requirement being we want to be totally agnostic of whether it's wired or wireless and whatever particular technology it is. And this is some list of advantages. I mentioned earlier that the brokerage or the service broker, he actually isolates the endpoints. They don't have a direct connection. They have to go through the broker. All packets are checked at an endpoint so that they can defend against cyber attack, as I discussed earlier in the use of transversion. Policy administration that can be applied to restrict packet actions, which is what I talked about earlier. But another capability you're able to get is directory services. I know if people on the call have worked in plants, being able to tell what are the devices you have. The only thing we normally would have had is a tag list, and maybe somebody somewhere has a wired list. Well, if we can have from our brokerage the ability of listing what are the devices that are registered, which ones are online, what are the characteristics of those devices, so on and so forth. I think there's a lot of things we can do from a common network management perspective. That's what I was saying second. And of course, I mentioned advantage integration of mobile devices, and I think if you've happened to have bought like an Android, like I did recently here, I can't seem to put it down. It has tremendous flexibility. It's a small mini type computer for a few $100s, and if I'm able to access systems in the plant and be able to view information that I need because I'm authorized to do so, it's a lot of flexibility. I think that's going to grow. I guess the overall benefits that I see, and I'm sure this is just a short list, I'm sure I could think of more, Applications, endpoints, and users are not exposed to this cyber attack because we have all those security mechanisms and a secure tunnel that we're able to put in place. All devices must be registered, as I said earlier, and devices can be viewed by mobile devices. Packets are inspected. I said this earlier. Device identity and use must be specified in the transducer profile. I mentioned that as well. Devices, applications, and users basically are agreed trust relationship. In other words, by stating them, that's been authorized to participate, they are actually part of that trust relationship. And the brokerage provides an unlimited scalability. Okay, I'm going to get into a little more on just Smart Grid itself. Everybody's seen this picture showing the landscape of Smart Grid. And as Irfan mentioned earlier, there's a number of standards that have been developed for specific aspects of the Smart Grid. And you can see they all are pretty much vertical there on the right, and they all come down where they use Ethernet and TCP. And for the most part, they're all generally exposed to cyber-type problems. So in general, I would say most people would want to keep those things off the Internet, and people will put them on a fiber or a closed network for many applications. But many aspects of the Smart Grid, we have to reach out to consumers. We have to handle many millions and go way off the normal path. And that's going to require using wireless and to do some types of things. And I'll try to cover this a little more later. But I wanted you to see this in a nice diagram, which I happened to get this from Francis Cleveland, which he did a good job of just kind of put this into perspective. These are all the concerned areas. I guess if you look at every one that I have listed, from generation, transmission, storage, distribution to consumer, we've addressed many of the endpoint types of concerns, but I believe there's still a gap. And that probably is best stated, like Irfan said, of it's a problem of interoperability. And that it's more complicated than that because of our security concerns. Of course, we're looking to move a lot toward the IEC 61850 series of standards, which most of the ones previously were listed are part of that. Many of them do require high-speed connections, and we are moving that direction over time. But we do have a lot of legacy systems that are still going to be around for some time, and it'll take time to transition those into IEC. And at this moment in time, I believe that the Internet is not really being effectively used because of those cybersecurity concerns. So the things that we're talking about are most relevant right now. I'm sure you've been hearing much of the discussion of what's called machine-to-machine. Well, everything I've just said are machine-to-machine. It's not just the idea that you'll take your Android and talk to a web page somewhere. We want to have real machines talking to real machines. Today we would use VPN, and they set up point-to-point connections, so wireless type of connection. And that works pretty well. But as you begin to scale the system, it becomes more clear. And there are some issues, which I can't go into all the details right now, but I have seen where end users have told me that when they get to a certain scale, then there were other issues. The public internet in general has been a concern because it's a single point where cyber attack can occur, and it's becoming more and more complicated for the asset owners to manage the complexity of incoming, outgoing traffic because they have to apply security. I know here in the facility I'm at in Chicago right now, security is a big issue, but we let all the office systems and throughout the enterprise be handled more or less by the IT people. But the plant systems are handled by the plant people. But yet we need to leverage these other systems. The smart grid, on the other hand, we need capabilities that allow point to multipoint with bidirectional communications and data sharing. And that's something we're going to cover here. I'm going to go over some use cases. That's probably why my file was so big. I'll try not to spend a lot of time in each one, but I wanted to give you a feel of the applications of where XMPP can be applied and what some people are doing right now. This first application is one for power line fault detection. We're doing some work with the Schneider Electric equipment synchrophasers. And this is actually one at the University of Buffalo and Buffalo State College. And it's basically to do analysis of how we can do better handling of the switching and relay systems for the power line distribution. But interesting enough, the people all wanted to have an Android device so that they could see what was happening and get alerts to be able to get some feedback from the system. This particular application is going to use Modbus over XMPP, but then use it in a pass-through mode and convert it back to Modbus. But in the middle, we have all that capability we discussed earlier, where the broker is able to perform all the functions that we discussed. This is another one for demand response. If you're familiar with the IEEE 21451.1.1, there's now a mapping that's been released to IEC 61850. And once again, we can apply the same principles that I said earlier, where we can bring in DNP traffic. And we now have a mapping to IEC 61850. But in the middle, which is XML, we can use XMPP, which basically uses XML. So today we would do this maybe at an endpoint to talk to the devices, to convert those protocols between D3 or 61850. Or as I show in this diagram, you can do just the opposite, where you want to transfer your 61850 to TNT. But in the middle now, we can leverage the same approach using XMPP and the new 1451 standard. Another area of use, renewable energy. I think this is quite a useful one because we are seeing now deployments of large-scale sensor systems. And we are seeing consumer-based sensors, solar systems. And in between, we're looking to make use of microgrids, and we're looking to use tie-ins to broadband over power lines. So we need to create something of an enterprise service bus. And I believe XMPP can offer that kind of capability where you now can tie in these various types of protocols using a common protocol, which we would call XMPP. That would be based on a standard. Just in general, I will mention this, that you can make use of the standard for new embedded devices. You'll notice from the diagram that we can tie it in, for example, a Modbus system, and still actually put the protocol directly into the device. You don't have to have a legacy protocol. You could actually take the 1451 system and put it into an end device. So in the future, we may see this kind of capability, which we're looking at an application right now where being able to do that under mobility, where the 1451 can be added as an app onto an Android device. And sensored systems connected to the Android now can communicate directly to the core, which would be a service broker that might be provisioned to be used for everything from telemedicine to you name it. That is going to be an interesting thing. This next one is what is called the UICDS SIM integration. And it's basically, you can learn more about some of this, about the Unified Incident Command and Decision Support System, which is a system that's been developed by the Department of Homeland Security, and it's hosted by SAIC. This is the web link to that. The basis of their system is a server, which is called the UICDS, and basically it's there for providing data sharing services for first responders, Homeland Security, Border Patrol, you name it. We're basically passing messages. You'll see on the right there's a cloud where the UICDS cores, we call them, communicate. They all use XMPP. And as you can see on the bottom, we can add our IPDX XMPP capability as a server suite, sensor suite, that can send messages directly into their core. So being able to create a UICDS core where the information can be shared with multiple groups can be very useful. I might mention that this system is now being deployed in California. There's tests underway right now for doing earthquake monitoring, and they're planning to put in sensors to monitor for cracks in roads. But it's going to be very important to tie in with utilities and be able to get information on the status of the power system as well. And it's to provide alerts to individuals that need to know. And those individuals may have portable devices, or there are existing systems that are used from the fire department, police departments, emergency people, hospitals, that if they're given permission to see this information, they'd be able to do that. And they all use XMPP today. This is an integration that was done from USOL, UISOL. They have a SIM system, which is on the lower side, that brings together many of the aspects that are concerned for the utilities. But you can see that by adding an adapter, they're able to move now the SIM data traffic into the core of the UICDS and provide alerts from a SIM itself. But again, we can even apply XMPP to help the SIM. I've met with people that have told me that today they're facing some issues. Mostly the SIM is relatively central located. To be able to get data from systems that are quite far away, we come back to the same problems that we had earlier. You have to choose the appropriate type of network and technology. And all those same issues still exist because we have to get that information to the core such that then the core will convert it to its packet format so it can send it within the SIM. But I believe XMPP can be very useful, and I've talked to them about adding an adapter even directly into IX so that they'll be able to do that even easier. This goes just a little bit further. That shows how, in conjunction of the SIM, how we can tie in various systems through that central core where we would provision a service broker, which could be located at the same location as the SIM, or it can communicate with multiple other service brokers and forward this data traffic back to the SIM. Okay, this is my last page, but it just kind of summarizes what my talk's all about. And I believe that XMPP is a major enabler for applications like Smart Grid because it's an extensible protocol. It can harmonize operations with other protocols. XMPP, of course, is technology agnostic and protocol independent, and it can greatly reduce the complexity and cost. I think you can see that how you're hearing this presentation. XMPP can provide a means of providing assured interoperability, scalability, and security. And leveraging the use of legacy devices to facilitate transition to new IEC standards, I think is an important one. And I believe that XMPP can offer a means of providing trusted messaging for users within the smart grid. Okay, that was my last slide, Erfan, and I'd be glad to answer any questions. That was quite a bit.
Wonderful. Thank you so much, William. And we are going to start with a question from Paul Duffy. It's a comment and a question. And he says that XMPP presents significant performance challenges for restricted networks like 802.15.4e and G and 1901.2 PLC type protocols. So would you like to comment on that? Yeah.
Well, that's correct, because I would not see sending the XMPP data traffic over a Zigbee network. We would use the Zigbee network, which they bring their data to a gateway. And for example, we even have an application right now where the Zigbee gateway has a MODBUS interface, and we can then tie in that gateway to the IPDX. And there, at that point, it picks up the XMPP data traffic. Now, if the 802.15.4 radios, which there's some new versions coming, which are going to be faster, would be able to support sending IP traffic like XMPP, that'd be great. I think we have to be aware that technologies need to be given that room to change and get better. And but I believe any technology can be used if it can pass IP traffic.
Very good. And we have a question from Pascal Sibon of EDF, who asks, we already have interoperability and security under the IEC 62351 within IEC TC57 protocols. Could you explain what features brings XMPP, or what features are brought by XMPP that are not possible with IEC standards?
Thank you very much. Hi, Pascal. I haven't talked to you in a while. That is a hard question because I believe this addresses the scale of use. It has built-in security that can handle that scale of use, and that interoperability capability where we can transport even legacy protocols. Again, I recognize we're moving toward more use of IEC 61850 type standards. Over time, we will get there. I believe that there's still a place for use of XMPP because it brings other capabilities like the presence capabilities and the need to get that information to things like mobile devices. Today, we have to do that at an endpoint, and it generally is brought to a database server. The database server then has to send it to a web server, and then the web server has to be configured to be able to communicate with the type of portable device. So, yeah, you can do these things. I've never said that it can't be done. It's just the complexity becomes more daunting, particularly as we begin to scale the system.
Pascal follows up with another question saying, XML needs processing to parse and could lead to security and performance issues. How do you protect from those?
Well, surprisingly, we haven't seen too much problem with that. It's not as bad as one thinks because we do have faster and faster processors today. People are even building these things into embedded devices. There is also some work within XMPP for providing compression, which since it is XML, we are able to provide compression that can't be done with binary data. That's something to think about. Hopefully that answers partially the question.
Next question is IPDX a device or an open source protocol?
IPDX is the name of a device right now, but it makes use of the 1451.1.4 XMPP. And what I showed you in the diagram earlier is the combination that when someone would implement the use of 1451.1.4, they may choose to do some things differently. But I believe that in our reference implementation, we wanted to show the capabilities that I've discussed. And IPDX is a product today that we hope to see grow into a service, which is going to be called IPDX.net. And I might mention for the group that we're working with various organizations, including universities, to have them share. There are a number of universities right now who are already involved with XMPP, many of which are in Europe, Finland, Germany, Italy, France, and Spain, to name a few. But I have had conversations with China, The Chongqing University has been looking at this problem, and we'd be glad to work with people to be able to try using this type of capability in their application. So be glad to talk to people offline about that.
And then he follows up with another question which kind of relates to the one he asked before. Using XMPP would ask to use a device on a high number of points and defining the associated services. Don't you think this will add complexity and less reliability to the grid?
Actually, I haven't had too much difficulty thinking about this because once you configure the device and like the IPDX, then you have a profiles of devices that allow you to recognize what that device is. And we looked at the idea that if you were to eventually connect up a device, it can be automatically recognized, and then you would possibly contact a provider and register it just like you would do your cell phone today. If you are authorized then to share that information with others, you could do so. Even in applications like we were just talking about from the Department of Homeland Security, if you wanted to provide that information in a way where you said, I want to have a third-party provider handle this data, then you could do that. They could just share their data through a cloud service with whoever needs that information. In this case, it might be the government. This may be the same data that you're getting back for some other applications within Smart Grid that's providing other information for you to make decisions. And as I view much of the use of a messaging-oriented system like this is in decision support, and ultimately everything we see in Smart Grid is geared toward making smart decisions, and we have to be able to provide that on a machine-to-machine basis so that we can allow those machines to know they're working with trusted data and be able to share that information with other devices, not all just people. And I don't think we've seen that just yet, but I think this is the promise that we would like to achieve with Smart Grid. And the complexity, I believe, is a lot less. There's still complexity, but it's not the same level of complexity that you would see when you scale the conventional approach that we do today.
Okay, I have a couple of questions from my end that I'd like to ask to connect this with the larger Smart Grid interoperability work that's going on in the industry, and I know you're quite active through your participation in various priority action plans as well as working with the IEEE. So one thing I wanted to ask is, where is this on the roadmap with NIST and the PAPS? And the other one is, have you done any outreach to the Open Smart Grid group that has several utilities that are working together to make specifications for various domains of the smart grid?
Well, I can tell you it's been a long path that it's taken some time to get to this point because I guess number one, we had to get it into the standards process, which even though it's been used, XMPP has been used, it's not, and it's been stated earlier as RFC and IETF, it had not gained recognition within IEEE till now, and it had not gained a potential recognition international within ISO and IEC. It is going to have that now. In areas like you said of Smart Grid, I've been communicating and working with people in NIST to make them more aware of these capabilities, which has overlap on a number of areas that they're working on, from machine to machine, Internet of Things, obviously Smart Grid. These are all more or less the same type things, including cloud computing, I might add. They all have the same concerns, and I believe XMPP is a really key element to make those systems work. So I've had meetings with people up to even George Arnold, which we need to have another meeting with him again and bring his team up to speed. There's a lot of work still to be done, to answer your question, Arifan, even though we've come a long way.
Is XMPP being considered as a protocol to be put on the slate of standards through any of the PAPs already, or is it work in progress? Where are we relative to other standards that are being considered to be put on the slate?
Well, many of the things that are happening within the PAP right now have already moved forward. They're using the standards that have already been listed for IEC. I don't think that they have looked that there are some gaps in there. I think in many respects, people see something work on a relatively small scale, and they say, oh, that'll work if we do it on a large scale. And that really is the gotcha. To answer your question more directly, XMPP probably has not been stated specifically in any of those PAPs right now. It takes time to get them introduced to it. Much of what I just told you today and the standards process within IEEE and IEC is really front edge, literally. And this was really timely because I can tell you within ISO there are groups, again, forming. They're not unlike what we see from the PAP group that have started. And those are in Europe and throughout the world. And they're in the exact same areas I discussed, everything from smart grid to IoT, machine to machine. And they are slowly working to the point that they're thinking about coming up with a common protocol. So we're introducing XMPP as a protocol that can meet those requirements at an international level. And as I've seen within the work within NIST, they are adopting many of the IEC standards. So I think it'll go full circle. It'll eventually come back that by now it is a IEC recognized standard. It has to also be considered in these other groups internationally. But then even within our PAP groups, we have to start thinking about that. But as I said earlier, I believe they're watching the activities of IEC for much of this standardization. And of course, IEEE will continue to play what they do. But it takes more or less keeping your foot in multiple groups, and there are still other ones forming all the time, which I spend a lot of time in a lot of different groups to try and be aware of what they're doing and hopefully introduce them to things like XMPP now. Hopefully that answers the question.
Yes, I think that the socialization process for a standard that is a disruptive standard, I would call XMPP a disruptive standard, and the reason is that you're crossing boundaries and reaching to the extremities of the smart grid in the hands of end users, as well as I'm thinking even engineers in distribution companies and transmission companies who are in trucks. So this is going to change the way we do business. And
well, I certainly hope so, Irfan,
yeah.
Actually, because as we've seen over the last few years, I believe there's been a huge investment and funds made available. It's been almost 2 years, and there's now more pilots that are starting. But I'm not sure that we're going to have all that money again like we got from our initial smart grid funding. I don't think our legacy systems are going to go away, but we need to enable the capabilities. And I can tell you from visiting a number of research facilities now, there's a wonderful amount of work that's been done, particularly for the endpoints to improve use of consumer-level devices. When I visited to North Carolina State University recently, Freedom Center, they were showing me a new solid-state transformer, and I said, wow, nobody thought about that. oh yeah, you need a bigger transformer if you have a power generating capability that's going to generate, hundreds of megawatts. And those transformers are expensive and very big. Well, they're coming out with a new solid-state transformer, but they still needed communications to that device, which they're going to use DNP. It's not IEC yet. So again, when I see these kinds of things being done within research, and I'm sure there are many, many others, we need to help them move forward and get into actual use and leverage our capabilities of the past, and eventually we'll slowly transition to the new things. But I believe XMPP and this messaging capabilities, which is pretty evident in our portable devices like Android phones and other things, are only going to grow. That whole part of our market, cellular as well as media players and other things, it is a huge business that it's just extremely compelling that invariably people want, as I showed in my presentation, I want to be able to see that. It might be just for getting an update and information. Things are changing very quickly.
Yes. So, I mean, what you're underscoring here, William, is this need for situational awareness. And as the number of nodes increases in the intelligent grid, it's really important to be able to have that situational awareness and be able to manage assets remotely and to have marginal and critical thresholds in place so that you go from a reactive mindset to a more proactive mindset, and you have the window of opportunity to take corrective action before it becomes business disruptive. And so having a friendly protocol that has the security controls in it to address the issues of the people who are concerned about, like, for instance, Mark Rand is asking this question. He says, will not having Android access be viewed as a big security threat, even with brokering and security? And then another question he asks is XMPP viewed as more applicable to DA than it is to AMI? So if you could address those two questions, then I'll conclude with some comments.
Yeah, in fact, I was just reading them myself. Clearly, it could be used in AMI applications. It can be used in many different aspects of the smart grid. The question with regard to Android, I would venture to say that if I was to answer the question of security use of Android today with standard SSL and other things, standard Android is very vulnerable right now. It doesn't have a lot of protection that you even have on your notebook. If I was to provision this with a XMPP connection using TLS and all the other things I just said earlier, I have a secured channel through the brokerage to the devices that I want to talk to in the field. And I have to be authorized to do so. So that's quite a combination. I mean, I can get a VPN onto this Android. I guess it's another downloadable app. But there are other problems right now, which Android is still evolving very quickly. And no doubt by this time next year, there'll be a even more powerful Android device. But it's very compelling what I see right now. But I believe with the addition of an XMPP capability, it'll be useful. I want to point out one little thing. A lot of people don't even recognize that whenever they make like a bank transaction today, you're talking to your bank's server, and you're using SSL. There is no intermediary. And we pretty much trust that we're actually talking to the bank. And I've had some conversations with people in the banking community, and they said, well, you know, you kind of need a broker in between, somebody that can validate that, is this really the bank, right? Because we don't have that today. And if you've been like me, I'll get an email in or somebody will show me a link, and I'm thinking I'm talking to the bank. And it's not. It happens to be a web server that's set up in Eastern Europe, in Estonia or something. And it looks exactly the same as my bank. And they want to get your personal information. So if you log in, they got it right away. We have those kinds of problems when we're dealing with the web. And today they don't have a brokerage mechanism for handling that kind of transaction for the financial industry. And quite frankly, I could very well see that use of what I've just discussed could be used in that way to make certain types of other transactions useful. But I guess you think about that you have to look at the architectural considerations and the fact that it's technology agnostic and it's protocol independent. We're able to empower people to use the existing technologies, make sure they're choosing the proper ones that gives them the reliability, reachability, and security. Hopefully that makes things a lot less complicated and much simpler for people to be able to deploy and use. Hopefully safer too.
Okay, we have another question from Mark Rand, and he says, the market often resists interoperability at some levels. Can you comment on the business impacts and the decisions companies will make?
As far as interoperability?
Yeah, because of the fact that it opens up, the different domains and exchanging information with each other. There's a certain element of openness that comes from interoperability. So that's why Mark is saying that markets will often resist that too interoperable is not a good thing.
Yeah, well, it comes back to what I was discussing about the activities within the Department of Homeland Security and the UICDS. I'll just use that as a reference. They develop a trust relationship. So in other words, if the state versus the municipalities and their systems need to share information, they make available certain information by agreement to each other. And this is kind of the same thing that we need to do if we're going to leverage the Internet for exchange of data traffic in something like the smart grid. If we wanted to exchange this kind of information, we can create, via the mechanisms that I've discussed here, a way of establishing a trust relationship. But again, the people who are participating have to have an agreement that says, I'm allowed to do this, and somebody has to administer it, of course. But I believe compared to not having it right now, I can understand why people don't really want to move toward use of Internet sometimes and would prefer to stay more closed in their networks. But if we're able to achieve trustworthiness of our operations, it takes more than what we generally use right now. And that's why I am very thankful that I've been able to share some of this with you so that you can see there's more that can be done.
Yes. And then there was a final comment from Mark Rand where he says it's the same issue in telecom where the concept of interoperability, there's some resistance from certain parties in that industry because of the vulnerabilities that would create. So on one side, you have interoperability enabling applications that were not possible before. And on the other side, because from a security and data privacy perspective, people have concerns when things are too open. So I think that, yeah.
I was going to say, in addition, because of the granularity that we can do in the system, you mentioned earlier on the transversion process, where today we might have opened up a channel that gave us complete access to someone's system. Well, if we're able to restrict them to only particular things of that system, more than what we do today, I think that'll be a lot more helpful. And it takes building that into the system. Today, we're only talking about censored capability. And clearly, it could be done even with other types of systems. But I think that kind of answers the question, to tell you the truth.
Wonderful. Well, thank you, William, for this very thought-provoking presentation on a protocol and a standard that is still relatively unknown in most circles of the electric sector. and I'm really glad that you brought it to the forefront, and the folks who are sitting on this call are very much involved in the NIST work as well as in the OpenSG work, and are trying to deploy smart technologies in their various infrastructures as utility folks as well as integrators and individual subject matter experts. So this was very timely. As you can see from this presentation and from the comments that I made at the beginning of this presentation, interoperability is a layered concept. We have very rudimentary 5-MAC layer interoperability, network layer, application layer, and then eventually semantic, business process, and policy. And William showed that in his presentation on one of the slides that he borrowed from Francis Cleveland. So this doesn't come without a price. As these protocols are deployed across the infrastructure, we have to be very cognizant of the benefits that they bring as well as the new challenges that they bring. And this is why it's so important to have such an open exchange, because the feedback that people like William get from presentations like this give them ideas of what to work on next within the protocols to refine them so that they better meet the business needs. Another thing that we are seeing increasingly is that there is a real proliferation of protocols and standards while everyone is trying to have interoperability, and therefore for a while we'll be in a situation of flux. Why this is the time when we will need these adapters that William has spoken about so that protocols can work seamlessly together across multiple domains. So while they exist as different protocols in different domains, they have very clear ways of exchanging data between them. And what William has presented with the XMPP is the possibility of networking sensors, devices that are way out on the extremities of the grid as well as at the customer premise, whether it be industrial, commercial, or residential. And this going forward is going to be very important because the overall stability of the grid is not going to be just dependent on a simple load from the customer premise and a bunch of centralized sources of energy. We're going to have increasingly renewable energy and a bunch of independent power producers. Consumers are going to be producing power. So in this kind of two-way energy flow, it's so important to have two-way information flow all the way from the extremities. So protocols that help us do that in a secure way are going to be very important going forward. And this is why a presentation like this is really important. And we're going to continue this series and bring other technologies and protocols going forward that you will see will fit into the different parts of the smart grid. Next month, on August 13th, we're going to actually have our webinar and seminar. The webinar will actually be a physical seminar, and NTS, the company in Southern California, has kindly hosted that webinar seminar, and John Thuart of Black Ridge is going to be talking about a very important development in the area of cybersecurity and how to secure TCP connections. And you're going to see that presentation on August 13th. And then next week on July 23rd, you're going to see the seminar, which will occur at the IBM Innovation Center in Foster City, California at 4 p.m., talking about the value of asset management. Why is asset management important in smart grid? How does it help validate sustainability projects? So you're going to see that presentation. And then next month on August 21st, we're going to have a seminar on dynamic pricing and demand response. And Ahmed Faruqi of the Brattle Group will be speaking about that and bringing some case studies on the effectiveness of demand response programs nationally. So as you can see, this Smart Grid educational series is trying to bring you different topics that we are all working on as a community, focusing on the critical issues, identifying the gaps, to excite you to participate in them in your individual ways, bringing your skill sets to it so that we can achieve the vision that Secretary Chu set up for us 3 years ago. So with that, I thank you, William, again for your wonderful presentation, and I thank you all for bearing with us as we dealt with the technical difficulties. As it turned out, it had a very simple solution where I remained the host and I just gave the desktop to William to present, so I will keep that in mind for the future. At this point, our recording is going to come to an end. So with that, I will thank you all once again and enjoy the rest of the week, and we will be on again on July the 23rd for our seminar. Thank you very much. Bye-bye.